So many people in the comment section of this video were confident that they could survive this, so let's talk about how it works. To understand how this type of roller coaster could kill you, let's look at the forces that typically act on you in a loop. Let's say that you go through this loop with a constant speed. Obviously you'd slow down a bit due to friction and drag and whatnot, but that's not important. Newton defined force to be the time derivative of momentum, how much your momentum is changing with time. Typically you aren't losing mass, so the mass is constant and you can take it out of the derivative. Then the time derivative of velocity is just acceleration, and that's the form you're probably used to. But let's look more at this term. Is the velocity changing with time? You might be tempted to say no because the speed is constant, but the speed is just the magnitude of velocity, aka the length of the velocity vector. Velocity also accounts for direction. It's easier to see how the velocity is changing if we compare each component of two velocity vectors. Here's vectors 1 and 2. The second velocity vector only has a horizontal component x, so there's 0 y component. The first velocity vector, however, has both a horizontal and vertical component. So, isolating each component, we see that the velocity in the y direction has decreased from 1 to 2, and the velocity in the x direction has increased in the negative direction. So, the acceleration vector would look something like this. I'm just freehand drawing, but when you calculate the force with a known velocity and a known loop size, you'll find that for a circular loop, the force always acts inward, and this is centripetal force. Your inertia wants you to fly off the track, but the rails act to change your direction. To see how this affects the body, let's draw the force acting on you at one location. The force goes straight through you towards the center. Your blood wants to keep going the way it was due to inertia, so it gets pulled away from your head. If you're going fast enough and for long enough, your brain will no longer have enough oxygen and you'll die. Now you might be saying, wait, the blood's getting pulled away from the head, that's a force, right? And that's sort of true. From your perspective as a rider, it feels like there's some artificial gravity acting on your body pulling the blood down. Even though from a stationary reference point, just watching the roller coaster, it's pretty clear that the coaster is actually pushing on you to stay on the track. So the force you're talking about is actually fictional, and it's called centrifugal force.